I know most of the people think the rare earths are important because they are scarce. That assumption is wrong. Rare earth elements are not rare in the geological science. According to U.S. Geological Survey, the global rare earths reserves exceeded 100 million tons. They are found in many parts of the world, including the United States, Australia, China, Brazil, and Russia. So the real question is not availability. The real question is this: why do so few countries actually control their industrial use? To understand this, we need to separate two very different things: resources and capability. Having resources is a geological fact. Turning those resources into high-performance industrial materials is an engineering capability, and that capability is far more difficult to build. Rare earths are not a single material. They are a group of 17 elements that typically occur together in very low concentrations. And separate them requires complex chemical processes, often involving hundreds of steps. This process is expensive, environmentally demanding, technically difficult. It cannot be replicated quickly. This is why countries with resources often lack control. For example, the United States operates the Mountain Pass mine, one of the largest rare earth deposits in the world. Yet, a significant portion of its output has historically been sent to overseas for processing because mining is not the bottleneck. Processing is. Today, more than 80% of the global rare earth refining capability is concentrated in one country, China. This is not just statistic. It represents a structural reality. The control of rare earths is not about who dig them out of the ground. It is about who can refine them, process them, and integrate them into industrial system. Now let's take a step further. Why do rare earth matter in the first place? Because they are not about quantity, they are about performance. The rare earths enable high performance systems. They are used in permanent magnet for electric vehicles. They're used in wind turbines for efficient energy conversion. They are used in jet engines, precision guidance system, and advanced electronics. Without rare earth, many of these systems can still exist, but they would be less efficient, less compact, less reliable, in some cases commercially unviable. This leads to a critical insight. Rare earths do not determine whether something can be built. They determine how well it can be built. And that difference matters because in modern industry, marginal performance differences translate into competitive advantage. A few percentage points in efficiency can determine cost. Cost determines scalability, and scalability determines dominance. This is where the real story begins. Rare earths are not just materials, they are performance multipliers. So the global competition is not about who owns the most resources. It is about who controls the transformation of those resources into industrial capability. In the next episode, we will explore a deeper question. If rare earths are globally distributed, why does the supply chain remain so concentrated? And what does that mean for the further future of global industry?